talk about building functions from functions in the way that we were just doing in the warm-up too, right? What does it mean to add functions or multiply them together or whatever? I think all those happen in the way that you would predict. And in fact, I'm pretty sure you all know this. In fact, I think there was someone in the summer packet that asked this, right? So when I come to this example down here, the interesting part to me is not like the algebra of writing down what f minus g is, right? Clearly, f minus g for this example is ln x minus root 2 minus x, and really there's no simplification to do. The more interesting question for me is this conversation today, right here. What's the domain of that? Let's kind of have a slightly more nuanced conversation. I know you know how to add and subtract functions and all that. So I'll give you a second to like digest what I've just thrown at you here. And then I want you to like think for a second about what the answer to that question would be. Keep in mind that you've already been doing this on the challenge problems. That first section of the challenge problems has some kind of crazy functions that are combinations of other functions. You've had to kind of think about this already a little bit. So this is not any different necessarily. No big surprises here, I don't think. The thing I added the star to is the key, right? The intersection of the domains of f and g. Also, if you're dividing, subject to this constraint also. That's not what we're doing here, though, so no need to worry about that. So it might be helpful for us to think about the domain of each of those individual functions. And then we could reconstruct the domain of the whole thing. Jeffrey, where are you? What's the domain of ln x? Just remind me.
0 to infinity, not including 0.
Well said. Okay. And Cheyenne, what about if you figured this is not one of our 12 basic functions, but have you thought about what the domain of g is? We're not even looking at this function down here yet. But for g of x down here, root 2 minus x. I mean, if you need a chance to think about it, you can. I don't know if you looked at it yet. But. Okay, and we just want to say what instead? Maybe just as a technicality, maybe we want to say negative. Yeah, negative infinity to 2. Including 2 or not including 2? Cool. And now we're finally ready to answer, I think, the actual question. Olivia, you want to take it? Where are you, Olivia? That is, what's the domain of this guy? So, sorry, say it one more time. 0 to 2. Yeah, 0, not including 0, to 2, including 2. Yes? It requires, obviously this function requires that any x value you put in be positive, and this one requires that it be 2 or less. So what are we requiring overall? Well, that, of course. And again, you could graph this just for fun in y1 on your calculator, and you'd see that it only gives values in this range and in this domain. And then if you looked on your table, you'd see that for other values outside this range, that you would get error, right? Okay. So again, the conversation here today is not really around the algebra of this first part. It's really, I'd love to have you think more deeply about the domain and what we're actually doing here. What's the deep stuff we're talking about? Just more practice on this one. Let's try these. Again, the first part's not the interesting part. I want you to think about the domain. There you go. You're welcome. What's the domain, though? When you're ready, someone maybe volunteer to give. I'll take a volunteer on this one. What's up, Alan? Good to see you. So, when you're ready, a volunteer on A. What do you think the domain is? You want to say again? I don't mean these to be too much different in spirit than the first ones on the challenge problem. You're volunteering, Joanne. Go ahead.
0, infinity inclusive of 0.
Okay, so yeah, I mean, again, we're thinking this one has a domain of all reals. It's just a parabola, right? This one has a domain of 0 to infinity, of course. And so it should be the intersection, right? So t is greater than or equal to 0. Do you guys agree? Go ahead, in the back. Okay, yeah, you remember, we did mention this. We said also subject to this constraint if we're dividing. So just with one small edit, it's cool. It's all good. Boom. Now it looks good to me too. Okay. What about this next one? Again, volunteer there. What do you think? You want to step out? Sure, say whatever you want to say.
So I thought it was 0 to infinity because since it's the same domain, it was never had to really go all the way to infinity.
Yeah, I think I agree with that. Remember, it's going to be the intersection of these two domains, so I guess we need to include 0. Okay. Now you said include infinity, but we don't ever include infinity on our intervals. Because can t take on the value of infinity? T may be any value up to infinity, but it may not be equal to infinity. You may not like actually plug infinity into the function. Okay. Good. Now a lot of you would be tempted to say once after simplifying this, what do you get if you simplify this? Just t. So a lot of you looking at that would say, oh, well, it's all reals. Well, but be careful. The thing we said still holds, right? The domain of the new function is the intersection of the two other domains of the two functions from which it's built. You just need to like remember. I actually would recommend you simplify this. I think you should. But you just need to kind of remember where you came from, right? Like you need to remember your roots. You know. Yeah. You know what I'm saying? Okay. I'm here all week, thank you. Okay, all right, so just be careful with that. If you graph this on your calculator, like if you type this expression right here into y1 in your calculator, you will see a graph of y equals x, except it'll only be the positive portion. You can try it, you'll see. You'll see. Okay. Let's talk about compositions. Another way is to combine functions. Yeah? I assume, again, that you know the mechanics of composition already, and that you're even familiar with this notation. But again, I think the trick here will be, can we successfully state the domain of these things? And simplify, too, carefully. Right? So this idea of composition is a powerful idea, right? That we apply one function, then we apply another one. So if this is like, if f and g are you washing and drying your clothes, which one's the washing machine? Which one's the drying machine? Yeah, which one's the washer? G better be the washer, right? It doesn't make sense to dry before you wash. G gets applied first, and then F gets applied, right? In that order. In that order. You don't like that analogy? I'm just saying the order matters here. We apply G followed by F. We always evaluate from right to left the functions, okay? algebraically, symbolically, it's just us like plugging in one function's representation into the other, right? So again, I assume you're comfortable with the dynamic, the actual mechanics of doing this. So let's write down what these are, and then we got to think about the domain too. So this will be what? We plug this in everywhere an x appears in the outside function. We want to replace it with parentheses and stick in the other function. So the outside functions. This is the outside function. It says take a thing and square it, and then multiply by 4. And into that we're putting the output of this function g. So we'll have to maybe resolve that expression. And down here, what do we have? We have the outside function is this. Take a number and raise it to the 3/2 power. And into that, we're putting the output of this function f. Okay? So maybe we want to simplify those too. I think that's a good idea. And we also maybe want to say what the domain is. So on the first one, I think we're all good on that. That's just 4x cubed, yes? What's the domain of that one? Think about the. Now, by the way, we should be clear here. This is a different slide. It's a different conversation. For combining functions in the way we talked about earlier, subtracting them, adding them, multiplying, dividing them, it's the intersection of the domains. That's not the case with compositions necessarily. So I wrote this cryptic thing. Write down the domain of f of g before simplifying the expression. So, okay, I'm looking at this. Let's be careful. What's the domain of this expression right here? Is there any restriction that we need to apply? If so, what is it? Go ahead. What do you think? Yeah, I mean, what's going on here? What is this really? It's a square root, yeah. So we need to make this be x greater than or equal to 0. Okay? Even though if someone just showed you this, 4x cubed, you'd be like, oh, all reals is the domain of that. So we just need to be careful. This is the function 4x cubed with the domain restriction, x greater than or equal to 0. Love it. Moving on. Now how do we simplify? Oh, good. We get an opportunity to practice our fractional powers. What is it? Don't be too excited about this. 4 to the 3/2 is. You got it. 8 times x to the 3rd here. Okay. Feels right maybe. What's the domain there? Let's have the same discussion. Think about this expression right here. Is what restrictions would you have to place on x if you have to place any? What do you think? I mean, I hear you say, I mean, yeah, we still have to worry about the square root maybe, right? Make sure that nothing negative gets, but what does 4x squared provide for us? Like, well, what happens if you plug in a negative number? I mean, this is kind of like a filter on this function, right? Isn't it? Like it ensures, this will ensure that anything that this accepts is positive already before it accepts it, right? So I think we're good. The domain is what? Okay, but just when we thought we were in the clear, I do have something else to say. We're wrong about this part. The 8x cubed. And the reason I can make that conclusion is because if I plug in 2 and -2, what happens here? I don't know what I get. But I know that both will give me the same answer. Do you agree? What's going on here, though? Exactly. And if you graph this expression and this, I think you find they're not the same graph. What's going on? Did algebra just break? I just want us to be like cautious. We always want to be thinking people. Remind me what's going on here? What do we have? I mean, really, the issue seems to be this kind of thing happening, right? Yeah. What's going on? Yeah, we need an absolute value in there, right? Keep in mind that this is equal to this, right? Okay. Just be careful. Just be careful. Do you want to say anything else about that? Tricky, right? I told you that we would have the nuanced conversation, right? You thought you knew everything about compositions, but we have to be careful, right? But you're ready for this. You know, you've dealt with compositions a lot last year, and you know how to do this kind of stuff. We're ready for like the whatever we are, IV, HL, pre-calc, magnet. We need like We're ready for this deep conversation, right? Okay. Whatever we are. Okay. Here's a fun problem. I think it's good. I don't know exactly how you would ask this question. Maybe this is the way to ask it, okay? Your book assignments might have a problem or two like this as well. I think it's an interesting puzzle. It is actually turns out to be an important skill in math to realize, like, oh, what we're looking at here is maybe a composition of two functions that I know more deeply, right? So, can you figure out what the two functions I composed were, is the question, right? What do you think the outside and inside function were here? What do you think it was here? Don't spoil it for anybody, though. Okay, don't. Write down your answer and compare with the person next to you. See if you got the same thing. Would you necessarily have to get the same thing? I don't know. That's a good question. Some of you have a really clear answer on the first one. Everyone agrees on the first one. Could you come up with another set of functions? By the way, by non-trivial functions, I mean don't make one of your functions what? It would be very easy to be like, well, one of them could be this function, and the other could be f of x equals x. Trying to discourage that, but I know what kind of
You know.
I do know. All right, I'm ready to hear from, wait for it, that's right, Disha. Where do I keep Disha? Where is she? Where is she? She's not responding. She doesn't hear you. Oh, over there. Disha. Can you tell me on A what you think F and G should be? That is, what do you think, by F I mean, what do you think the outside function was? And by G I mean, like, what do you think the inside function was? That I plugged in. You don't know? You're forgiven. You're forgiven. Gabe, what do you think? Okay. Hey, can I hear Gabe? Sorry, guys. I'm sorry to interrupt your conversation. That's my bad. I'm sorry. Okay, go ahead. Gabe. Yeah, okay, I think I like that. Is that what you guys said over here too? Okay, great. I think that works, and maybe, again, my challenge would be, could you come up with other functions that do that? I don't know, maybe you could. Okay. And then, do you want to take the next one, Disha? What do you think the outside and inside functions are? I just thought I'd give you a chance. By the way, I don't know, for the freshmen, I assume that you did some composition of functions, but maybe you didn't, I don't know. Okay, well, now you did. Okay, let's pick someone who's a sophomore. Brilliant, go ahead.
It could be f of x equals, so f of x equals the square root of x plus 1.
Okay.
And then g of x equals x cubed.
And are there other ways to do that, other people? Okay. Right, there's not necessarily, you could also do, what, root x and x squared plus x cubed plus 3, x squared, x cubed plus 1. Anyway, whatever, the point is, can we recognize a composition like in the wild when we see it? I think that looks like someone composed two functions, I think. Okay.
Natural habitat. Be careful. These things.
All right, let's talk about something truly weird. Okay. This is just we're shifting gears just a little bit. Full disclosure. It's just in this section of the book, and I don't know what else to talk about. So here, let's talk about it now. Implicit functions is something we want to talk about. That is, there are things that are important in life, that aren't necessarily functions. Like we like circles, for example. Who knows what this is? I don't know. Who knows what that is? But we can still talk about it. It still presents to us a relationship, doesn't it, between x and y? And we can ask, is this one of the implied relations in that that equation entails? How are you doing it? What are you doing? I mean, all you have to do is ask, is it true? I mean, does it work? Try each one and see which ones are in the relationship. And then ponder in your heart, what is this thing? Who knows? I'll show you. There it is. Pretty cool, right? All right, so let me hear from a couple of you. Shivani, what'd you say for the first one?
It does satisfy.
Shafay on the second one?
No.
And Michelle on the third one? You, Michelle. Did you try the third one yet? Well, don't say yes with like a cringe look. Like you say it with confidence. Come back and let you do it for a second and then try it. So everyone agree on the first one, yes? And no on the second one, and then we're not sure about the third one yet. You say no? She dialed in. You say no, a yes on the third one? You sure? Yes? You know, no, you meant. Is it or yes? Okay, you guys agree? By the way, now that I have the picture, we can spot these on here too. 2, -5 is somewhere. 2, 1, 2, 3, 4, 5 there. 1, 3 is not there. It's up here, and it doesn't lie on this curve. 2, 1 is right there. Yes? I don't know why it's not projector shapes. It's because subtle movements of the earth below us. Okay. Now, sometimes you might wonder, how did I generate this picture? And the answer is I had a computer do it. Okay. In general, it's actually fairly difficult to come up with a way of doing this. In fact, it's not even easy to plug points into it and figure it out, right? For every x value you plug in, you'd have to like solve for y each time, and you can figure it out. But then, what about, you kind of need to plug every y value in too and solve for x, right? You need to like plug in a whole grid of points to text or something. I don't know. Kind of weird, right? Sometimes though, you can make your life a little easier. You know what you can do with this guy, right? Can you solve that for y for me? Not easy, or might be not even possible here. On this top one, I don't know how you do that. But on this one, that's not too bad. What do you get? Y equals, well, yeah, the shape of this is a circle centered at the origin of radius 2, right? So what do you get when you solve for y? You get some kind of square root, right? Square root of 4 minus x squared. Now, of course, what does that give you if you graph it? It actually only gives you, because it's a function, it only gives you the top half of the circle, doesn't it? The positive root of that. So we should actually maybe include both parts. Both of these functions, you might say, are implied by this relation here, right? So there's a nice example with one that you do know and love. It's a circle. And we could do the same kind of thing with a hyperbola or with other concepts that you might know and love. We could actually maybe solve them for y pretty quickly. If they're, oriented up or down or left or right at least. Cool. Fun so far? We having fun? I mean, this is a very, very rich, in some ways, unstudied area of math. I mean, this kind of curve is not not everything that could be known about these curves is known. I mean, we know basically everything I feel like we need to know about quadratics. We've got it in the bag, But a curve like this, not as well studied in math. And in fact, like I said, when I look at that equation, I don't have, because I'm a seasoned mathematician, I don't have an intuition as to what that looks like. I'd have to kind of figure it out with you too. I think, okay, well, I think I can convince myself that without looking at the picture, that there's symmetry over the y-axis. Could you maybe? I don't think about it. From the form of the equation, because there's an x squared. Whatever. But in general, it's hard to have a feel for these necessarily without the help of a computer. Needless to say, we can still try though. So let's try on some of these. See if you can figure out what these look like. Huh? No? You can try if you think that would help. If you can. Yeah. If one of them kind of stymies you, try one of the other ones, right? Think about what set of points. Just start plugging things in, right? Which kinds of points work, you know? Can you find even one solution? I don't know. I'm going to wait until the very, very, very last minute to show you these three pictures. So just try to work till the end of it and convince yourself. We only have like 2 minutes. Alright, I'm going to show you the pictures. So then the task will be different. The task will be why. Why does it look this way? Here's the first one. 2 parallel lines. Did you figure out why it looks that way? If you haven't, you still have work to do. This one just looks like that. The set of all points on the x and y axes. And what's the last one? Is everything? Everything but the x and y axis. Shit, yeah. Alright, so think about now, like I said, now your task is to figure out why these plots look this way. Okay? And I don't want to give anything away. That would be me stealing your joy. Okay?